So hello everyone, today we'll be integrating this question and it has got a trigonometric function, hyperbolic, not normal but hyperbolic trigonometric function. So let's see how this is done. So I've always told that in questions like this, you have to try and make this, change this into the form of sine and cos and then divide it by cos square x, and similarly, get it in the form of tan and sec. So that's what we will initially try, but then let's see if that is necessary. So let's change tan in the form of cos and sine and sec in the form of cos. So is equal to, tan can be written as sine hx over cos hx times 1 over whatever we have here in the denominator, cos hx does not need to be changed, and then plus, of course, 64 times sec hx is 1 over cos hx, and of course the dx. We might have missed it over here. Let's write it. Yes, wait, let's write this d properly. So dhx. So something that you should think of is the number 64 is not very common, so you have to understand, you have to think why the question is given number 64. So the only significance of number 64 can be that probably we'll use it as 8 square, otherwise 64 does not have real other significance. So let's keep that in mind and let's move forward. So after this, what you can do is take LCM here. So is equal to sine hx remains as it is times dx divided by cos hx multiplied cos h square x plus 64 over cos hx. We just took the LCM. This cos hx cancels this cos hx. So now what we have is sine hx over cos h square x plus 64, of course, times dx. So now you must be having some problems. How do we change it? How do we bring this sine h down, or how do we change it into tan and sec? So you don't really have to do that. You just have to remember the basics of integration, and that is, if you can somehow get the derivative of the denominator as the numerator, things get very simple. So what we'll try and do is, if not exactly, what we can do is we can let cos hx is equal to p, and let's suppose that. So let's differentiate p with respect to x, and we will have sine hx. If it were normal trigonometric function cos x, then it would, the derivative would have been minus sine x, but since this is hyperbolic, the rule is a bit different. So we get sine hx. Yes, so now what we will do is dp is equal to sine hx times dx, and what we can see, or is trying to go to the next page. Yes, so what we can see here is we have sine hx times dx, so we can write it as dp, isn't it? Yes, it is. So is equal to now dp over cos h square x is p square plus 64 remains as it is equal to dp over p square plus 8 square. Yes, so what we had assumed previously, that 64 can be used as 8 square, has come true here, and we know the formula of a square plus x square, the the integration, something like this. We have already done it in many questions earlier, so it's going to be very simple. We're just going to apply the formula. I hope you've remembered it. It is 1 over a over here is 8, times tan inverse x over a. So x can be considered as p over here, and a is 8 plus c. And finally, this is not our final answer. We have to express it in the variables that were given to us in the question, that is using x. So 1 over 8 as it is, it's just a number. Tan inverse, the original value of p is cos hx over 8 as it is, plus the integrational constant. So there you go. This is the final answer to this question. Nothing very difficult. All you have to remember is to link derivative and integration as we did in this step. So yeah, this is how you do it, and I hope you learned how to do this, and hope to see you in my next videos. Thank you.